All right, for our final concept of Unit 10, we're going to be doing some calculations to look at our boiling point elevation and freezing point depression due to the collective properties. So the addition of a non-volatile solute, one that is not going to evaporate, to a solvent causes the boiling point of the solvent to increase and the freezing point of the solvent to decrease. We can complete calculations to determine the actual change in temperature that these phase changes occur at. So here are two formulas. You can see the slight difference is that we have a plus sign or a positive sign out in front of our calculation for our boiling point and a negative sign out in front of our freezing point depression. We're going to use a constant, and I'll show you what those values are up on the screen. Alright, so here are units, explanation of that. Delta T is our change in temperature of our boiling point or freezing point. KB or KF is our constants of our solvent. Lowercase m is our molality of solution, which remember is in moles per kilograms. And I is a factor that we are going to be able to do because of our last concept. And this is basically asking us how many pieces does this particle break up into. Alright, so here are those constants specifically for water. If you work with a different material, we'll have a different constant. So calculate the boiling point of a glucose solution that contains 0.4 moles of glucose and 350 grams of water. So here's our formula because we're looking at boiling point. You're going to see that when we plug in values, remember that let me just pull up this pen very quickly. Remember molality is moles over kilograms. So I'm plugging in my 0.4 moles up here. Again, M is this part right here. And then 350 grams of water divided by 1,000 gives us 0.35 kilograms of water. Now, glucose is a molecular compound. So I is equal to 1. So that's why you have I here being 1, and then we're working with water as our solvent, so Kb is equal to that 0.25. When I solve this all together, I get a change in temperature of 0.59 degrees Celsius. So that's our change in temperature. Remember, the boiling point of water is 100 degrees, so 100 plus my increase of 0.59 degrees Celsius means my new boiling point is 100.59 degrees Celsius. All right, in our next example, we're going to be working with freezing point. The student determines that a solution of sodium chloride has a freezing point of negative 4.68 degrees Celsius. How many moles of NaCl are present in a 250 gram sample of this solution? So we're going to be working with our freezing point. Now we went from 0 to negative 4.68, so that's going to be our delta T. We have our constant that was given to us before. Again, M is going to be this part of our equation, moles of NaCl, that's our missing value, over kilograms of my solution, which is this amount here, 250 gram sample. And then I is equal to 2 because we get Na with a plus, Cl minus our negative ion, so I is equal to 2. So that's where this 2 comes in. So you really need to be able to break apart those ions and recognize ionic versus molecular in order to get the correct I value. And then when we solve appropriately for our missing variable of moles of NaCl, we find that we need 0.31 moles of NaCl in order to drop the boiling point or the freezing point by 4.68 degrees. Okay, we will be going over this actually for the next 2 days, so just get a basic understanding and we will spend a lot of time in class on this